And now we have all the tools that we need in order to solve the problem posed at the beginning of this section. So we have, just to remind you, we have two stations that are 20 miles apart, and there is an airplane in the air, um, which, and the angle with the ground from the first station is 15 degrees. The angle with the second section station is 35 degrees. Can we figure out the height at which the airplane is cruising? So the problem is the height. Let's recall the height is a perpendicular line to the ground. So the problem is we know this total length, but we don't know exactly how this height will break this entire side. We cannot assume anything. We cannot say, oh, we have 15 miles here and 5 here. We don't know that. So we actually need to know some other parts in this oblique triangle. So for example, if we knew side A, for example, this side, then we could use our sine and to find the H, right? Um, so let's do that. We would say sine of 15 degrees equals H divided by A. But we need to figure out A first. Well, how can we do that? Well, if we look at this triangle, we know two angles, and we know one of the sides. So if we know two angles, we can find a third angle. Let's label. So this is gamma. Oh, alpha, I'm sorry. This angle is going to be alpha. Let's say this is side C, this is gamma, beta, and B. All right, so since we need side A, I'm gonna say sine alpha over A, and then I'm gonna involve gamma, sine gamma over C. Okay, but we don't know gamma. Well, once we know two angles, we can easily find the other angle. I'm going to do it on the side right here. I'm going to say gamma equals 180 minus 15 and minus 35. So gamma is, what is it? It's going to be 130 degrees. All right. So now I know my third angle. Now I can keep going. I can keep on solving this ratio. Now I know everything in this ratio except A. So A is C times sine alpha divided by sine gamma. So it's going to be 20 times sine of 35 divided by sine of 130. All right, and so that will be approximately, so A is approximately 14.975 miles. So now I can go ahead and actually substitute it in here in order to solve for H. But actually, I want to solve for H. First, I want to multiply both sides by A. I'm going to have A sine of 15 degrees equals H. So plugging in A, I will have 14.975 975 miles multiplied by sine of 15 degrees, and that equals h. All right, I'm going to put this into a calculator. And what I'm getting is h is approximately 3.9 miles. All right, and that's going to be my answer. So the height at which the plane is flying is 3.9 miles. And it's the actual technology. That's how we can tell the height of the planes that are flying. This is actually, they're actually using trigonometry to figure it out. Okay, now I want you to try a similar problem by yourself. It says the diagram shown represents the height of a blimp flying over a football stadium. Find the height of the blimp if the angle of elevation at the southern end zone, point A, right here, is 70 degrees, and the angle of elevation from the northern end zone, point B, is 62 degrees. And the distance between the viewing points of the two end zones is 145 yards. Okay, so this problem is very similar to the one that we just did. So I trust that you can solve it. Again, pause here, and I'll see you in the next video for section 10.2.